This is our Mousetrap vehicle. We thought it would be funny for it to be made out of badly cut pieces of cardboard. We used CDs for the wheels as they are already very circular and have the same interior circle space as one of the wheels from the CO2 cars. Combining these aspects with our mousetrap and dowel rod lever, we are able to string a fishing line across our car and pull the front axle forward, driving the car. The spring of the mousetrap is the source of force, always attempting to pull the lever back to its original position, meaning that the force will travel through the lever and apply tension to the string. This tension pulls on the axle, rotating it and the wheel with it to create the car's motion. The initial force, however, does get pulled into overcoming things like friction between the wheels and the ground and the axles and the car, reducing the actual output when the force is turned into rotation.
This means that the mechanical advantage of our car, that is, how much more work is done than what is put into the car, can be a lot less than the true potential of the car. By comparing the distance in and the distance out of each simple machine used, we can create a ratio of how the distance change occurs. However, you can also compare force put in and force gotten out to see how much energy was retained, but it will never actually reach the same ratio as the distance in to distance out. This is why the distance ratio for mechanical advantage is called the ideal mechanical advantage, as it acts as though the force being put in is the exact same as the force coming out. Using these aspects, we can understand a good estimate of the advantage of our car without having to measure the force being placed on the axle throughout the full run of the car. So, ideal mechanical advantage can be written as distance in over distance out. In the first instance of this can be found in our wheel and axle ratios, which are 0.4 centimeters for the axle and 12 centimeters for the wheel, which, placing axle over wheel, gives us 0.033 as our mechanical advantage for this part. The other part is in our lever, where the distance in from the spring's movement is 2.8 centimeters, and the output distance from the full lever is 16 centimeters, giving us 0.175 as our mechanical advantage. By averaging these values, we can find the total advantage gained by our system to be 0.00583, such that a higher advantage is for an increase in force, and a lower advantage is for an increase in distance. Overall, by looking at the way our car was designed in the aspects of physics, such as mechanical advantage, friction, and forces, we can understand the way that these objects interact with each other, as well as the world.